we put together some ideas, some examples on how IMS, how Cenosco has been working with data integration coming from different sources, right? And allowing an effective degradation management that's quite important for our segment, right? So if you have a critical asset that will degrade, you need to make sure that you're taking the appropriate actions. So I'm going to cover one example of one module that how we can process that. Before going ahead, we're going to talk a bit about Cenosco and IMS, where we come from. I'm not sure if everybody is familiar with that, so I will take a few seconds to talk a little bit the story, talk about data integration. What is that? How the integrations typically work. What is a degradation management and how we can integrate that data? I give one example of that automation, how to collect data from sensors, robots, or any kind of new device. And what is the main takeaway from this? Why we here? I don't think we need to go over too much on the reason we are here and that degradation exists, right? Corrosion exists, and it's almost $3 trillion every year to replace, mitigate those corrosion issues, right? There are problems with leaks, so those industrial facilities they are aging, and as they age, they degrade and they cause leak, and they can cause catastrophic consequences, right? So it's very clear that that industry, that segment can be oil and gas, process industry, any kind of engineered asset will have those issues. And based on that, Cenosco was created with that need to digitalize, to create systems to manage that integrity, because companies realized there was a big issue for them and something had to be done. Cenosco started in 2000 on that first wave of that what I call RBI software, right? So that risk-based inspection software, they were basically RBI engines that would create an inspection interval. So Cenosco, was since the very early ages, we've been working together with Shell. We also inherited or we acquired those methodologies from Shell that we use today in our system. So back then, 2002, we had a system called RRM. That RRM had three modules for inspection as an SRBI, for reliability as an SRCM, and for safety instrumentation as a CIFPRO. That was primarily like a risk management tool, right? So you identify, so it was more about identifying the risk, quantifying the risk, and create an interval or a task, yeah, an inspection task. But that would stop there. That information would be sent to an IDMS, for example, an inspection data management system, to do the planning and execution. At that time, we were working exclusively for Shell until 2011, when we reached an agreement that we could commercialize, we could sell that application to anyone in the market. Things continue to evolve on that relationship, and then we start to incorporate other solutions into IMS, right? So it became from RRM as a risk management to an integrity management tool in 2014, when we incorporated corrosion calculations, we incorporated these degradation management, the IDMS capability, the inspection planning, execution. 2020, the founders decided it was time to let the company grow and receive further investment from Fortino. That led into 2023, the acquisition of Cenosco. We acquired the intellectual property of the tool of IMS. So since the end of last year, IMS is fully owned by Cenosco, and then all the drive and the steer of the product is now lies on Cenosco with the help of all the users, yeah? Not only Shell, but all the users that come on board. Bit of a background. Vision. I'm not gonna go too much in detail on these, but that partnership make us strong, right? Technology make us a true leader in asset integrity management. We have key assets in upstream, down, midstream, and downstream across the globe. So you go Australia, Asia, Europe, Africa, America, South America. We are everywhere. And then we created over time, we created libraries. Yeah, libraries can be a library of failure modes, can be library of inspection reports, methodologies, right? Those methodologies, proprietary methodologies, which means that you're not going to find some of them out elsewhere. Of course, you can find the RBI methodology in other places, but the Shell methodology is quite unique to us together with an integration, right? So we're going to talk a little bit more about integrations. Typically, those integrations are done with the CMMS, right? So you receive the asset register, what we call the asset hierarchy from SAP. Yeah, that's just the starting point to do any kind of analysis. And because of those libraries, the methodology, and the experience, we can implement the solution in a very short time. Working in all mobile device, we made that progress into the field, so allowing inspectors to fill in checklists that can be used in our degradation. I'm going to cover a little bit on that. And of course, user experience and feedback has been quite important for us. Modules, I'm not going to cover every single one of them as a highlight. IMSPI, that's the module that I'm going to go a little bit more in detail today. That's related to pressure equipment integrity, RBI, corrosion calculations, barrier management, inspection planning, and execution. Very robust, one of the key products that we have within the IMS platform. Followed by RCM for reliability, that it includes like not only rotating, but electrical equipment instrumentation. IMSS for safety instrumented systems, a system also very robust with a methodology that was created even before IEC with a unique failure rate database. Pipeline and subsea systems called PLSS. Again, very quantitative module that will consume ILI data to calculate corrosion rate, remnant life. FCM for flange connection management, calculate torque and tension to create a plan, right? And allow the maintenance crew to perform the maintenance on that flange properly and record the results. It's more like as a quality assurance process. As an add-on, I'm going to talk, of course, in addition to that IMS sync, that is the capability to share data with other systems and other equipment. I also give an example of that IMS Air 3D as a remote inspection management. So how are we going to use a drone or a robot to take photos and process that in a very automated way, right? A landscape, if you want a more website, that I've done basically webinars and content about all those disciplines. Yeah, so you feel free to search for that or get in contact. Going to data integration, right? What is integration? I think a lot of people in the inspection area that is not too much in the IT. I'm not an IT guy. I'm a mechanical engineer. Understand how integrations work, right? So what is an interface? Interface or integration, quite related names, right? I often talk about the interfaces. And an interface is a communication protocol, right? So we have two systems, and these two systems need to share data. They need to push a planning, receive a risk ranking, share a photo. So the systems needs to communicate. But these communication need to be based on specific protocols, specific rules, using specific technologies, right? Which I'm going to cover in a second. Those technologies within IMS, we are quite flexible to accommodate different technologies. Those technologies can be simply sharing access to a database, can be through a notification. We send the message and that message contains the data we're going to consume in the different systems. There are different technologies. Your company will likely have a preference for one of those technologies, right? The REST API, very common, right? But we need to see how is your IT architecture to accommodate that. Some of the examples is about asset hierarchy. We receive the hierarchy from SAP, right? So whenever there's a change in that asset hierarchy, we need to receive that in IMS, and that's very critical for integrity. You need to make sure that you have the reliable data in your hands. So receiving an accurate list is fundamental, is really the beginning of everything, of any interface. Then you can share specifications, right? Material, usually material is not managed by an inspection department, for example. So it's going to come from engineering, and those engineers will use another system, such as a digital twin or a document management system. And that data will flow back in IMS, and we might take some actions. I'm also going to cover that in the degradation management, right? Integrity data. So if you have a permanent sensor, for example, right, like PermaSense, and you take wall thickness measurement, you want to send it back into IMS, can be done. If you have a crawler, there's different applications that you can use that integrity data flowing back into IMS. This example is a lot about wall thickness measurement, right? Wall thickness measurement that we use for corrosion calculations. ILI data, if you have an instrumented pigging, for example, you're going to consume that data, run fitness for service, yeah, corrosion calculation, rem and live, and manage the integrity of that asset. Okay, so that's the integration. So that's the background on the integration, on how data will flow back and forth from IMS into other systems. Some of those integrations can also be done through like an import file, an Excel file, right? It does not need to be necessarily a connection between systems. For example, the ILI data we receive, like if you go back into that integrity data, ILI data flows back into IMS through an Excel file, right? So we receive that the inspection results through an Excel, and then we just import. There are technologies to allow that integration, or you can import. It also considers an interface. We call that just the manual interface, right? You just have an Excel file in between. Then we talk about degradation management. That's the key. Degradation management framework is a methodology that we have in IMS. It was originally called corrosion management framework. So if you hear a lot from Shell specifically, they call CMF. We rebranded as a degradation to make it a little bit broader, the concept. So that degradation management framework defined the practice, responsibility, resources, ensuring that degradation management satisfies the integrity objective, right? Integrity objective is going to be zero leaks, for example, right? With the purpose of providing guidance to an inspection plan to process, to report the effectiveness of that mitigation, right? Identify, so that methodology will allow you to identify threats and implement barriers to prevent those threats from happening, right? It's a very dynamic methodology. It's been created by the upstream business of Shell, where they had the offshore platforms and they wanted to minimize, the use of inspectors in the field was quite expensive, limited availability. So we implemented those methodologies. Early Ages was an Excel file. A few years ago, I think 5 years ago, we implemented thoroughly the CMF or the DMF into IMS, yeah? Allowing that continuous degradation management. And what is that workflow? Yeah, the outline of that is we identify the threat, right? To identify that threat, you need to understand information about the asset. So that integration that you have from your specifications will be quite important. We can define corrosion loops, grouping components, right, that degrade in a similar way into a loop. Identify the potential degradations, right? So now we identify that that corrosion loop is subject to CUI, for example, right? And then what do you do if you identify that equipment, yeah, with that material, with that temperature, with that pressure, yeah, with that insulation is subject to CUI? Now we're gonna think about how we're gonna design the barrier, how we can identify the barrier, assess the barrier, and do that verification and maintenance. So that barrier design is about assigning a barrier to a degradation, right? If I have CUI, I need the barrier as a coating, right? I might need to have an integrity operating window, right? Depending on the degradation mechanism. And one of the libraries that we have in IMS is that library of barrier type per degradation mechanism. So we call them common barrier types. So very quickly, you implement the barrier, the degradation, and you know which barriers are more common for that degradation mechanism. That library saves a huge amount of time when you're designing them, right? And finally, the barrier verification. And a lot of things go around that barrier status, right? So implement the barrier as a coating, you need to make sure that the coating is in good condition. If that barrier is not in good condition, yeah, your degradation will start happening, right? So you lose effectiveness of that barrier. So, a normal action would be replace or repair that barrier, or, restore the status of the barrier. On the corrosion loop, for example, I'm not going to go deep in here. Corrosion loop is about grouping components. Components are section of an equipment, yeah? And those components we need to have a similar material of construction, right? Operate in the same condition. Therefore, subject to the same degradation mechanisms, right? Very common approach in any RBI methodology, right? Identifying the loops by material and the potential degradations. That will lead later on, I think, to a corrosion control document. Today we do the other way around. So we build the corrosion loops, we do the RBI analysis, and the outcome of that will be populated into a corrosion control document or a CCD. So threat identification, barrier design, right? So the barriers are created to mitigate or reduce the risk of those threats, right? To as low as possible. Few different barrier types, for example, there's a material selection, right? This will define, is that material of construction compatible or resistant to the degradation, right? If you have, so you're gonna have different, for stress corrosion cracking, there's some material that are more susceptible, there's some material that's less susceptible. So there's gonna be a material design where we're gonna consume the specifications, basically. Coating or cathodic protection, preventing that external corrosion, right? So that's a barrier. Get process control. Process control, we're gonna monitor IOWs, your integrity operating windows, looking at temperature, pressure, flow rates, and so on. You can monitor a chemical treatment if you have a corrosion inhibitor, oxygen scavenger. So those can also be considered as an IOW, right? And typically a lot of sites these days, they are taking those analysis or that data and bringing that into a data historian, right? Which we're going to use that later. Right? So then you have the barrier design. We identify the threat. We implement those barriers, right? And then we need to look what is status of that barrier. So remember, a coating is a barrier. So I need to make sure that my coating is always in the green condition, right? The barrier is fully present, active, and effective. If for some reason, after typically an inspection, and here that's where I'm gonna come into using of robotics or any kind of automation, how we can identify quickly that the barrier has been compromised, right? Or is partially effective. right? So if I have a coating as a measure to protect my piping against external corrosion, if I do an inspection and I identify my coating is in a bad condition, my status will change to amber. Say, oh, that's bad. Or if the degradation of my coating is really severe, I'm gonna switch to red and say, no, the barrier is no longer existent. So when I change the status to red, we're gonna send kind of a warning, not a warning, but we're gonna show that barrier is red to all the components within the same corrosion loop and say, listen, one of those equipment had an issue with coating. You have to pay attention, yeah, because likely these degradation will also happen in other equipment in the same loop, right? If you fix that barrier, but you're still pending an action, we can bring in yellow. But the objective is always bring to green. Yeah, evergreening is the word. And whatever you have, you don't have any data is going to be blue, right? So status, how are we going to convert and integrate data coming from different sources, different systems, different technologies to update my barrier management, right? That barrier status, as I mentioned, will be shown and will depend in different factors, and will show in different stages of that inspection planning and execution. Yeah, whatever you're doing your corrosion calculations, right? You're gonna see there is a warning here that you have an issue with the material. That's probably why you have a high corrosion rate, for example, right? If you're planning an external inspection, right? And you see that that barrier is of coating is red, right? The inspector already knows that he needs to, he's expecting for something. And those status will be many times will be updated using inspection data, right? I talked at the beginning about having IMS in the mobile as a checklist in the field, right? Fill in the checklist depending on the outcome of the checklist, right? So if I say I found an issue with the coating, right? That coating issue will update the status of my barrier. If I have a corrective action, if I have a coating issue, it's going to be, my status will be red. If I implement a corrective action, right, it will become yellow. If that correction is implemented, it goes back to green. I will review specifications. I will review wall thickness measurements. There's going to be a number of sources of data, right? We're going to look into IOW, right? IOW is the same concept, right? So you define the upper and lower limits, and whatever you operate in that limit, you're safe. If you go beyond those limits, it might be a little bit dangerous. So we're gonna update the status and say, yeah, that integrity operator window is out of range. We're gonna flag and record those exceedances, right? We're gonna record those exceedances and give it back to the corrosion engineer. Process engineer says, what do you want to do with that? Review that exceedance, right? And then if that exceedance was a one-off, you just ignore. If there was a process change, you have to go back to your RBI, go back to your corrosion calculations. Likely, if your temperature went up, your corrosion rate will change. So that will trigger some additional verifications that at the end of the day have to be done by people, right? They still have to go back and review that outcome. Barrier verification, it's an ongoing. When you're talking about an integrity management system, it's a lot about verifying, verification, monitoring, inspection, right? So hardware barriers, when you focus on the piece of equipment, right? So you look at RBI, we calculate corrosion rate, we take wall thickness measurement, right? And other results capture in condition history. That condition history is typically an inspection report. And that inspection report will receive data from other systems, right? So like a PermaSense, it can be a drone, can be a crawler, yeah, it can be any kind of device. And then you have your process barriers. So We're gonna update process barriers through a data historian. Yeah, we're gonna connect with the OZPI, for example, and receive and process that data. It's a high level, right? We're gonna have a degradation mechanism, corrosion, thinning, or CUI, or stress corrosion cracking. We're gonna implement barriers. Those barriers will be monitored by indicators, right? Those indicators will be updated based on different sources through an integration. So now we're coming back through the integrations that we talked before. How that data will come back through an Excel file and a wall thickness measurement can be an automation, right? It can be an IOW process data historian. Yeah. All of that data will come back, we will update the status of the barrier. And therefore, at the end of the day, you can uh, look at which barriers are compromised, which barriers have status as red. From those barriers in red, which equipment have a higher risk, which equipment are bad actors, right? So it facilitates the prioritization of your corrective actions and your inspection planning, right? So that integrity verification is where we bring all the data together from different sources. Now, if you have a specific equipment, a specific technology that you're starting collecting data, let's talk. Let's see how we can convert that data into an indicator status. That's fully configurable from the user interface. Of course, Cenosco people can help you, but the concept, the indicator, the definition of what is an indicator, if corrosion is severe, if an external corrosion is severe and you have that much loss, get pitting, you update the status, right? We give you some default indicators out of the box, but users will be able to create them. Facilitating and enabling that decision-making process with data. So we are crunching data, we are integrating data from different sources. Dashboarding for corrosion engineers, just to visualize in IMS and say, okay, those are my barriers, right? I see I have a coating problem with coating and painting. So you have 19 of those barriers related to coating are red. Whenever you interact with that bar, it will bring up which degradation mechanisms are related to those barriers that are in red. We have IOWs. What are the risks of those equipment that are suffering from that degraded barrier? Visualizing, crunching that is also a very important part of the degradation management. Good. Now, one example of these automations, right? How we receive data from a specific piece of technology and how we can crunch that into IMS, how we can process that. We have an air process, right? So it has autonomous integrity recognition. That air, we call air 3D sometimes, is a technology that we developed together with Shell, C3, and Microsoft, where as part of an open AI energy initiative. If you want to know more about that open AI energy initiative, there's a very nice webinar that we did with Shell. Dan Jevons from Shell, one of the creators of that initiative that led to this technology. Basically, the objective of these is enhance remote inspection using drones and artificial intelligence. Personally, I come from an inspection company, right? So I personally qualify as a drone pilot, implemented the drone technology in my previous company. So we've been trying to use that. And I think now that technology is very mature, right? So you can fly a drone as a screening tool, right? And process that data in bulk using artificial intelligence. And how we can do that? We're gonna capture images of the equipment. So you fly a drone in a pattern, that drone will take pictures. The AI and the machine learning will analyze those images and identify degradation within those images. Can be mechanical damage, can be corrosion, can be coating, right? Can be, but it's external. It's a screening. So you will only identify things that are visible from a drone perspective. Don't expect identification of internal degradation or a crack, unless the crack is huge, but we identify. So far it's easy, right? So not that difficult. I think we've been exploring that for a while, but the machine learning process that was implemented in this process came from 30 years of experience of photos from refineries that were recorded in IMS from long time, right? We provided a repository of what bad looks like, right? To teach the algorithm. And of course, there was a lot of people, a lot of to train, yeah, to teach that algorithm. And the key fact that we do here in the technology, this is sitting on the IMS side, on the Cenosco side, is how to map an image to an equipment automatically. So if you imagine you fly a drone, you capture, 10,000 pictures, and then we selected 50 of those pictures, right, as having an issue. How are you going to identify the equipment that photo is related to? So in IMS, there's a recognition of that image through 3D model. So we correlate the data in the photo with the 3D model and create a condition history, right? So create a condition history that needs to be further analyzed, right? High level approach. So we capture the data, right? It can be a drone, it can be an inspector walking around with the camera, or it can be a robot, walking around. I've seen a lot already in news. Those Boston Dynamics dogs, right, with the camera on top of it, and you just say, walk around, do an inspection round, once a day, and then look for anomalies, right? And then you can also look at the trending. So capture the data, observation scanning, yeah, 3D localization. You're going to map an anomaly to a 3D model. And we create an observation, right? That observation is it's an action item for a real inspector, for example. So we create the observation. It's not an issue yet. It's not an anomaly, but it's an observation that somebody has to review it and classify as, yeah, we can neglect, we can say, don't do anything, but we can also say, create a corrective action, say, fix that issue, right? So in that case, the inspector did not have to go into the field, but he can also trigger a new inspection. Say, okay, I found an issue. I need to verify more the extent, send somebody else, send an inspector for that equipment. So the key here was how to map that piece of data related to a condition, an external condition, to an equipment, to an inspection report. Challenges the evolution. That process, apart from changing names, yeah, that autonomous integrity recognition, it was called autonomous or automatic image recognition. So the term AIR has many names reflecting the different stages of that project, right? At the beginning, people were skeptical, say, I'm not going to use it. So there was no clear use. There was a vision, say, okay, we have to use the technology, right? Then over time that changed, right? So the capture of the drone, but creating that use case. And that's also applicable for other new technologies, right? So if you have a technology, if you have an automation that you want to work on right? Let's create the use case, how that data will flow. There are technologies today that can prepare that data, that can work a little bit more on the field side. Um, like the guys, yeah, there's a company in Germany, for example, that will scan your digital radiography and extract the wall thickness measurement, and then we're going to process that. So that process of crunching and reviewing and processing data and handing over to IMS, so IMS can implement an effective integrity management, right? So key takeaway. So the project highlight the critical need for a robust infrastructure, right? And how to operate AI in the field. So it's a success story. A lot of the shell sites are already using it. They have the infrastructure behind. Uh, Initially to kind of teach the algorithm, but now I think it's a ongoing operation that the users are quite satisfied and save a lot of time for inspection, for external inspection, for example, for us as a screening tool. Yeah. Um, Conclude, right? Next generation inspection and degradation management powered by integrations, right? So touching that key integration, how we going to bring that data that can transform in asset integrity management. Enhancing inspection, I think inspection will happen for a number of years, except for new facilities that will probably come with the built-in technology to monitor integrity. For now, existing assets needs to be inspected, needs to be verified by inspectors. A lot of compliance within pressure equipment, those have to be accommodated. Uh, so authorities would not recognize an autonomous inspection as to take credit for a mandatory inspection, for example, but for sure it will improve accuracy and efficiency, right? Um, and adopting those technologies will keep companies competitive, right? Ensuring a sustainable operation. Sustainable operation is about using the less resources you can, right? Uh, to make sure your asset it's in operation, is available, yeah, and have good reliability. Get good reliability and availability, your profitability will be high, and you stay more competitive, and you can survive today's market. So that's the story I had to tell today. Thank you for Tina and Sprint Robotics for having us here to bring a tiny piece of IMS to these very specific audience. I'm happy that everybody stayed until the end. Still see 38 people here. If you guys have any question, let me know. Let me see if I can get something here.
Okay, thank you very much, Luis, for this very informative presentation. To kick off the Q&A, we have a question from David Richardson. He's asking, did you do any screening of the input images? I often find that there is variation in the human interpretation of external condition.
That's the key of the AI, right? So we don't process this, we don't screen the photo in that process. So if I come back here, that observation scan, we're gonna import that data, right? So we're gonna take bulk tens of thousands of images and we're going to plug into the algorithm. The algorithm will identify by itself, right? And then later on, we're going to verify. We're going to do what we call a remote inspection, right? That remote inspection is the final screening before taking an action. I agree with you. At the beginning, the quality of that AI, the machine learning, was not as good, but today it's been helping a lot, and there's even more sites joining every day.
Okay, for the next question, we have a question from Dario Sosa. He's asking, how do you compare with software from robotics developers like Gecko Robotics?
I don't know that specifically. I know some of companies involved with robotics, they will have a specific piece of technology. So if you have a system, or if you buy a hardware that will give you some analytics capability, that is fine. But and then we're going to focus on the integration of the outcome of different systems into IMS. We're not here to solve all the problems for integrity, but we're here to consolidate. So if you have a specific technology, hardware, drone analytics, you can still use that, but make sure that you bring it back into an integrity management system so you can make sense of that data coming out as an overall integrity management system. I don't know that technology specifically, but I'm going to look for it.
Okay, well said. So the next question would be from Mr. Carlos Perez Martinez. He's asking, um, how do you integrate? Can you tell us any current use case deployment? How long how long will it take it to deploy? And the next question is how many data is being recorded? Any significant impact?
Yeah. So this example that I've shown here is a very clear example of those integrations, right? So that's a technology that has been implemented. There's the development part that took a few years, yeah, to come to the stage we are today. The key challenge in this particular technology that we have is the need of a 3D model. That's the only way we can map an anomaly to a physical piece of equipment is through a 3D model. Yeah, having that point cloud technology, right? Sometimes that's a showstopper, right? So if you don't have that 3D model, if you don't have that digital twin capability, that technology will not be able to be, you will not be able to implement. So this is a real technology. There's a real product that is available. It's being used. It's very mature at the moment, right? We got a lot of lessons learned on that. So that's what we bring typically. Other integrations can be perma-sense, right? It's a sensor that will receive that will collect the wall thickness measurement, and we're going to process and run corrosion calculations. Those interfaces are built on demand, right? Depending on the architecture of the user. The amount of data will be the amount of data you want to, how you want to interpret that data, right? And how you want to push that into IMS. Sometimes, if you look at advanced NDT, for example, phased array, we don't process like phased array data within IMS. You do that outside, but you bring the outcome, the results of that analysis into IMS, and that will trigger that integrity management or the degradation management of your system. Good.
Okay, and then I think we have two more questions. The next one is from Dario again, Dario Sosa. He's asking, how do you integrate or partner with robotics developers, as for example, the PIGs?
I mean, we are people company, right? So you still need to sit, you work on a use case. So one of the key facts that we had here as a learning, yeah, is to define a use case. What do you want to achieve with a specific integration? Which kind of data is available? How am I gonna map? How am I gonna integrate? So the big experience from these and other integration we built is to create a use case. How are we gonna integrate? What is the value that's gonna need? What's gonna value that's gonna add, and how are we gonna process that further? So I think for me, creating a use case for any technology integration is I would spend half of the time in building the use case. Yep.
Okay, thanks for that insightful comments. And then the last question I think would be, can you share an instance where data integration and automation have enhanced inspection in IMS?
Yeah, I mean, I think the time I can for sure give you a live demo on how that integration, how that automation. But here we are talking about going back to that degradation management. So the automation, for example, and the integration will update the status of my barrier. So this is red. If I have a barrier, yeah, that is red, it means that there's an automation working. It means that I process inspection data, robotics data, any kind of data into a status. And that status will trigger an action, right? So if you're a corrosion engineer, for example, you cannot see any reds in these dashboards, right? So that automation, that integration will create an action. Corrosion engineers will not care about overdue inspections, right? But they care about degraded conditions, right? So that for me, that's the biggest example. How many automations, how many integrations we have? We have use cases for each of these barriers, for example, coming from different systems. It also depends on the technology available on site.
Okay, so last two questions. One is from Gear Tori Nodsen. Can you use parts of the IMS system? For example, integrate IMS with other 3D models for visualization of the data?
Yes, yes. So actually, I'm here in Dallas today, joining a Hexagon event where we showcase the integration between IMS and Hexagon digital twin that's called SDX. So we can share inspection results in their 3D model. At the same time, we can consume drawings, isometrics, and all the data in IMS. Although IMS have its own 3D visualization capabilities, we have full capability to integrate with all the digital twins. That's for sure. Good question.
All right. So another one from Marcelo Magalhaes Gular. Any AI applications for corrosion detection and assessment?
Any technology for corrosion? Again, we are on the technology, on the software technology area. Um, we consume typically data from other technologies, right? Now, we use the basics, right? If you have a pigging, yeah, we can process that pigging data and run remnant life calculations. And there's a number of applications and a number of use cases that we can demonstrate separately. Yeah.
Okay, so Marcelo, I hope Luis was able to answer your question. And then lastly, for a conclusive question, where do you see the potential for integrating robotics data with inspection and degradation management processes?
How do you see the possibilities? I think inspection is still pretty much manual, right? There's a visual inspection, there's a non-destructive testing. A lot of the robotics comes on the maintenance side. Um, I think that visual inspection is still the bulk of the work. It, I think there's going to be more and more sensors to monitor the condition of the equipment. I think in the future there will be. But my take today, and I was talking, the whole week with other asset owners, is that before going into after new technologies, there are technologies that are available, methodologies that are available, they're not fully implemented, right? So we still see companies that don't have an integrity operating window. They don't connect with the data historian. So before going, giving a step too far, do the basics, and then we look for automation in other areas. That Air 3D for me is I was the one that's skeptical at the beginning and say, why are we doing this? And now when I see the value of it and how the process was streamlined, for me, it's a huge the technology is widely available, right? The algorithms are running. We get the machine learning already understanding what is the issue. And then you can have a clear process of recording those inspection results again as a screening tool. I think for me, those are the key areas.